Cool. So I kind of wanted just to show what I used for my workflow for the stream that I did a few days ago. And the main idea is we're kind of working in this multi-document setup as you see here. And this is a pretty simple setup, so like simple robot. So as you like increase your workflow, it'll be a little bit, you'll have more documents, but the main ideas remain. So we kind of start with our main assembly, which is just has all our sub assemblies, and this is important because, well, it has our intake plus our shooter, and our intake and our shooter assemblies, as we look in here, these are based on our master sketch, which is right here, and it'll take a little bit to load, so it's whatever, but we have everything kind of based on this master sketch right here. And I don't actually have anything named, but it's fine. But the idea is we have the sketch, which I call it sketch 1 as here, and this has all of our main driving dimensions. And this helps me kind of figure out, okay, so this is the direction and all, like the path that the ball is taking. Here is all the rollers, the top, the up and down position of the intake, and the shooter position. And then once I model this layout sketch, we can also do like a crayon CAD visualization, which I use the crayon CAD library. And this helps me visualize, okay, so if I wanted to communicate this with someone else, what would the robot generally look like? And you can see here as well, the master sketch does line up with the crayon CAD. Although the crayon CAD is slightly different, but it doesn't really matter that much. It's mostly for packaging and communication reasons. If we just look up like crayon CAD, and we see the beta 1.7.5, we can import it from this assembly, and we can grab all like these various assemblies and import it. And you can also change, and they're all configurable, so crayon CAD's cool here. Something that I do, which is a little bit different from other teams potentially, is I like to have my drivetrain in the same part studio as my master sketch, because I usually derive my drivetrain into my other part studios. And I'll talk a little bit about why. But, so I made the master sketch, I made the drivetrain, and which the drivetrain is based off the master sketch, and then I made the drivetrain assembly over here. And once I made that drivetrain plus the master sketch, if we go to our intake, as we see here, and it'll take a little bit to load, but our intake is going to also be based off that master sketch and that drivetrain. And oh, it's okay, so it's in context right now. Let's delete the context. Okay, I haven't actually opened up the CAD since the stream, so it's whatever. But actually, we can already see here, as I try to wait for Onshape to let me exit the context, if it will let me. Okay, there you go. We can see, here's the derived feature. So I derived the master sketch, which you see here, which was in our part studio for the drivetrain and the master sketch. And then we have our drivetrain, which is just a drivetrain. I don't really have anything to say. And the reason why I import my drivetrain, as you see here, is that lets me when I work in my part studio with the intake, I can work in relationship with the drivetrain and make sure that like I don't end up having like this tube hit the swerve module. So just being able to have all the mounting points and just work in relation with everything else makes it super duper easy for me to just mount things to the drivetrain and make sure that things don't clip. And then you can see here, we derive the master sketch, and then this goes, and you can see how the intake is based off this master sketch, like the pivots here. And if we go and look at our sketch 1. This sketch is based on that pivot. And then I do some, for the belt center to center distances, I do some slight adjustments in this part studio. So it's not exact, the roller locations aren't exact, but they're close enough. So it's usually fine. If you wanted this to be exact to the master sketch, you'd calculate your belt CCs in your master sketch. So it's all preference. I think it might actually be better to calculate it in the master sketch, but it depends on what your priorities are. So once we do that, we model all of our parts in the part studio, and then I just go into the assembly and assemble it together. And something you'll notice throughout the part studios and the assembly is, if we look at the origin, that even in my assembly, the parts are in the same location as they were. So if I like insert my master sketch, let me see if I can find it. Let's see, master sketch. Yep, if I import my master sketch, you can see how the intake is also in the same location as the master sketch. And then you can see how the master sketch is also in relative to the origin, in which the floor of like if the robot is laying on the floor, the origin is in this location. So I try to make sure that that stays consistent. And then yeah, just a revolute, nothing crazy. Just make sure everything's in the same location. I don't really care too much about like foldering and whatever, but for best practice, you can folder all the similar parts and whatnot. If you're just doing solo CAD, it doesn't matter as much, but I'm just going over what I was doing in stream, so yep. And then if we go back to our documents and we go back to our shooter, the shooter is pretty similar, so I won't really talk too much about it, but the same idea applies. We have our part studio, we have our assembly, and you'll notice how I only have one part studio and one assembly, and there isn't really anything else. Like, the document structure is pretty clean, and that means it's really easy for me to navigate and model things. And if we look again at our origin's also at the floor, as you see here. So the floor of the robot, and the parts are all being built relative to that middle center of the robot. So if we looked at a real robot and we looked at the center of the robot to the floor, the parts would also be in the same location. And then the same idea applies. We imported our main sketch, and then modeled our secondary sketch based on that master sketch. And especially when you're doing large plates like this, it gets a little bit fancy, but as long as you're doing the arcs properly, the sketch shouldn't look too messy, as you see here. And then, yeah, I do a lot of COTS imports, so I use MKCAD for that, but I assume you already know how to use MKCAD. And then, same idea, origin's in the same location, relative, so if I imported the master sketch again, let's see if I can find it. Other documents, layout sketch. No. If we import the layout sketch from the master sketch, or the master sketch, doesn't really matter. You can see how the sketch and the plates in the assembly all are in the same location, and same with the origin. And it's also centered, as you see here, and it makes things look very pretty. Once we go from our shooter, we can go to our main assembly, and of course in our main assembly it's going to have all of the same principles, with the origin on the floor and the sketch being in the same location, and everything kind of fits together nicely. And that means that, like in this one, I only actually have one mate, and I'm not actually sure why I only have one mate. Oh yeah, the shooter is not mated. Oopsie. Oh well, it doesn't matter too much. I can mate that in like 2 seconds, but you get the idea. So if I were to mate the shooter, then it'd be mated, but you can see even when imported the shooter, right? The shooter was already in the right location, so it wasn't too difficult. But yeah, that's basically my entire workflow. It's pretty simple, but it allows you to design robots really fast. So like you can do this whole thing in like, what? This was 6 hours-ish? And I mean, yeah, that's it.